Hello everybody. In this video, I'll be once again discussing or answering some of the questions from general chemistry or introductory chemistry. The first question I have here is aluminum combined with oxygen. Aluminum combined with oxygen forms Al2O3. Similar to that, they're asking what would happen with indium when it reacts with oxygen. So this is where you have to look at the periodic table and get the valence number and crisscross method. So let me just do aluminum. Aluminum is group 3. So it could have 3 plus here, and oxygen. It's 2 minus. So when you crisscross method comes, you get Al2O3. That's how we got that. Now indium is also in the same group 3 of 13. Group 3 of 13, just to make sure that 3A of 13. So it's boron, aluminum, gallium, indium, and thallium. So indium again, indium is 3 plus, oxygen 1 is again 2 minus. So they're given this close, so it's easier. IN 2 or 3. Right, you need to have the periodic table. You can derive so much information from the periodic table. So make sure you select the periodic table that has all this information, and then on the sides you can note down certain things, so you have all the things written on a single page. That's okay. So the next question: what is the expected chemical formula? So this is about chemical formula. If you have magnesium and bromine, so bromine is in the group 7A or 17. So its valence is -1. Magnesium is 2 plus. So when you crisscross, you get magnesium Br2. Because what it says is we do the crisscross easy means magnesium 2 plus. Okay, so that means to neutralize boron, one boron giving negative and the other boron giving the other negative. So that's why MgBr2. So that will be the formula. And the next one is what is the expected formula when silver plus phosphate 3 minus. Again, you do the crisscross method. But only thing is Ag is 3, phosphate, this is easier here because, okay, PO4, you can just write it like that. But otherwise, this plus charge goes to the entire thing. So you can write it like that, or H3 PO4. You have to understand this is a polyatomic anion. Polyatom. So that's the answer, Ag3PO4. That's how you get the answer. It's important to know how to get the answer. The way to do is you have to know your theory well, then the application comes. So this is because naming of compounds, they are asking what is CaI2. So the name is calcium iodide. Okay. So it's a group 1 or 2 aluminum or zinc. Other than everything else, you put iodine. Ite is the end. You write the first name as it is at ite. Please review your naming of compounds theory part, worksheets or theory part, whatever you have used for the class. The question is, what is the name of SF4? SF4. So this is going to the next group where you write the first one, sulfur. And this, because there are 4 there, you put tetra. Fluoride, so you just, it's fluorine before. So ite part is sulfur tetrafluoride. You don't write mono or something if it's just 1, but if it is more than 1, you would say whatever that number in the same way, di, tetra, like that. So in this case, is sulfur tetra. So it's 4 fluoride, FAU or write it. Okay. Fluoride. Just write it. Okay, another question I hear asking about name of this compound. So it is cobalt. Oh, sorry. It's like oxygen, so it's cobalt is small. CO like that. That's cobalt. So cobalt. The other part, it's nitrate. But in parentheses here we put because it's coming from the transition metals in the D series. So nitrate. So what should be? There are two nitrates. So normally nitrate is -1. Okay, this is a polyatomic anion that has only one negative charge. So if you have two, another three, there is to neutralize these two negative charges, you need to have two positive charges. So that in Roman numerals we put this number to match that charge of the cobalt. So that's the name of cobalt 2 nitrate. 2 is this Roman numerals too. What is the charge of manganese MnO2? So they're asking if you put MnO2, what is the charge? So this is the oxidation states. Oxygen has -2. So there are two of them. So 2 means -4. Now, in order to neutralize this -4, because MnO2 as it is, we haven't put a charge here. No charge. No electric charge. Okay. So Mn would be +4. Plus where -4 cancelling. So the answer to the question is, what is the charge of manganese in the manganese Mn in MnO2? So that would be +4. Okay. So you get that. All right. The next question is, which element is diatomic? So what exists normally? So they have given a list of choices here: magnesium, phosphorus, carbon, and bromine. So from knowledge, bromine normally exists as Br2. So group 7, chlorine, bromine, fluorine, they all iodine, they all like that. And even other ones are oxygen, nitrogen. So these are diatomic. So from the list given here, this answer is bromine. Okay, here the question is empirical formula. Empirical formula is the smallest possible formula, complete integers. Okay, so they have given a compound C8, 6O4. So what you do is you try to simplify the same thing. So in order to get a simplification, if I divide all by 2, I get 8 divided by 2 C4, 6 divided by 3, O4 divided by I get 2. So the answer would be C4H3O2. Determine the empirical formula of compound contents. Okay, so they're asking again to determine the empirical formula, but what they have given is they have just given the percentages of the elements available in a compound. Okay, so the percentage given now, what you do, you write the compounds they have given, gallium and fluoride in this case. So 55 and 45. These are the percentage. You know that percentage part, just write 55, 45, divide by the respective molar masses. Okay, so in the periodic table, let me see what is for gallium. It's 72. Is it 73? 7 because it's 70. Oh, sorry. It's looking at Germany. Sorry, gallium is 69.72. So I'll make it 70. And for fluorine, it is 19. So I divide by 19. So when I divide like that, I get 0.7, say 0.79. And here I get 45 divided by 19. I get 2.37. So then after that, divide each by the smallest number. So smallest number is this, 2.37. And then mass divided by the molar mass. Right, did I get it right? Okay, so I have gallium 70, and so if I divide it by 70, 2.37. So if I, oh, sorry, so 2.37, the smallest is 0.79, so I divide by 0.79, I get 1 here. So always divide both numbers after you get the number of moles. Here, what you get is actually n, which is number of moles, because so for empirical formula, you try to get the smallest, so 0.79, 2.3. So if I divide 0.79 by 0.7, I get 1, divide by 0.79. 2.37 divided by 0.79, I get 3. So my answer would be GAF3, which is the answer for the empirical formula. That doesn't mean it could be the molecular formula. For that, we have to see the molecular mass and then get the empirical formula mass and compare it. Okay, so the answer is this for GF3. Okay. Now here the empirical formula of carbon hydrogen compound. So they have given the empirical formula of a CH compound. Here they say empirical formula of a carbon hydrogen compound is CH. Formula of CH compound, that means carbohydrate. I'm sorry, hydrocarbon compound is CH. So the empirical formula is given. They say the molar mass is 78. Okay, they're asking what is the molecular formula? It's the MF molecular formula. How do you do that? First, find the mass of this empirical formula. So carbon 12, hydrogen 1, you get 13. Now see how many 13s are there in 78. So if you divide 78 by 13, which is same as divide the molecular formula mass divided by empirical formula mass. Okay, so if you divide 78 divided by 13, I get 6. So which means I have to C6, H6 would be the molecular. Okay, the next question is about the coefficient of lead in the following reaction. So the PBS plus PBO, PB plus SO2. First step, because you have to balance it. So coefficients means what are the numbers coming here. So in this case, they're asking lead. So we have to find what number gets here. But at this point, I'm marking here. So to do that, we have to balance it. So let us see. Sulfur 1, that's no problem. Oxygen 2 here. So if I put 2 here, then oxygen 2 is satisfied. So lead, how many? 1, 2, 3. Right? So if I put 3, then it balances. So the question is, what is the coefficient of lead? It would be 3. The coefficient of BaO2. Now they're asking BaO2 in the given reaction. So the reaction given is BaO2, dissociation or decomposition, BaO plus oxygen. So let us see whether it's balanced. 1 Ba, 1 Ba, right? 2 oxygens there, 2, but there are 3 oxygens, right? So if I put 3 here, if I put 3 there, then I have 3 barium, then I put 3 barium here. So if I put 3, 3, then it doesn't match here, right? So let us take it back. Let's go start from oxygen. So there are. So if I get I have to get some even number, it's easier. So if I put 2 here, 2, 2, 4, 2 there oxygen, then 2. So 2 barium, fine, 2 barium, oxygen 4 altogether, there's 2 here and 2, 4. So that's so the coefficient would be 2. That's the answer. Okay, the other question. H2O for this the question of H2O, giving H3PO4. Okay, so let's see whether it's balanced first. It's phosphorus, 1 phosphorus, 1 phosphorus. That's right. Then chlorine 5. I don't know 5 chlorine. So if I put 5 here, what happens? I have the 5 chlorine there. Then hydrogen 3 and 5, 8. So I put 4 here. That's covered. Then 4 oxygen there. So that's all done. So the coefficient of water would be, okay, because it's first you have to balance it, then get the number coefficient. Okay. Right, the questions I have here have all about coefficients. This is coefficient of oxygen. Okay, so C10, 22, oxygen, CO2 plus H2O. You know that whenever a hydrocarbon is burnt, or this is a combustion reaction, you have to know the types of reactions at this level, either introductory or general chemistry level first. But oxygen, then you get carbon dioxide and water. So you have 10 carbons here. So if I put 10 here, hydrogen I have 22. So if I put 11 here, then I get that balance. Then what oxygen? And if I put here, that oxygen is 20 and 31. Yeah. So so if I put 10 here, there's oxygen. Oxygen is 20. Okay. Then to match this 22, if I put 11, I get 31. All right. So 10, 20, 31. So if I put 31 here, so this is 60. Total should be 63, right? 62, sorry. 62. So do it. So to balance, if I 31 or so, if I make this 20, I have to make a double 20, right? So 20 now here 20 becomes 40. So I have 40 because the total here is 62 oxygen atoms. So 40 here, and if because this is 2, that means 44. To get 44, I have to make it 22. Then I get 44 here, right? Then I have 44 hydrogen, but oxygen I have only 22. Hydrogen 44. Here this one again, now that I have got the answer. Okay, so this is the correct answer. Why I got it? Because total here, oxygen I get 62, right? Carbon 20, here 20, so that's right. Then hydrogen 44, here 44, that's right. Then let us see oxygen. Oxygen, this should be 62. So 20 times 2 means 20 times 2 means 4. means I have 40 here, and oxygen I have 22, so totally 62. So the coefficient of oxygen would be 62. That's the answer. See, it took some time because you have to balance it. As I said, I'm doing this contour, check it, and then balance it, then you get the answers, okay? It takes some time, but you have to make sure that this is correct, then only you can get the correct coefficient. All right, I have here again another coefficient question. Coefficient of KNO3, potassium nitrate. Let's see. So the phosphate plus KNO3. Okay. Now when you get this parenthesis and all, it might confuse. So make sure that calculate them correctly. So let us say copper 1. There's copper 3. So I put here 3 because copper 3, right? Then copper is fine, but let us see whether you have to change those figures. So nitrate, we have 2 and 3, so 6 nitrate should be there. But KNO3 here only is it, so I put 6 here. So this is right. Now, what about potassium? Potassium 6 here, there's only 3, I put 2 here, 6 there, potassium, okay? Phosphate then should be 2, so it's balanced. So the question is, what is the coefficient of KNO3 means here, what figure? So that would be 6. This was pretty easy because, but if you're going to break it down to nitrogen and all, it will be difficult. So try to recognize these as polyatomic anions, and you keep them together and you can calculate too. All right. The next one, what is expected formula for magnesium and phosphorus? So once again, what do? You go to the, see which groups each one is. So magnesium is 2+ so group, and phosphorus will be 3-. So if I do that, go to these groups and check it, okay? So answer would be Mg3P2. Okay. Okay, the other question is again the formula. When aluminum and sulfur combines. So aluminum is 3+, sulfur is 2-, crisscross method, Al2S3. Right. The next one. What is the expected formula again? Cr3+, NO3-. They have given the charges. Okay. Now what do you do? Again, it's crisscross. Okay. Why do you think they give 3+? Because chromium is a series, right? It is transition metal. It can have many charges. So this is 3. So when they give 3, NO3 is always minus. So when you crisscross, there's only 1 and 3. So NO3 3 times. Make sure it is for the whole thing. So you need to have parentheses. Okay, so that's the formula. All right, the next one, what is the compound formed from an element in the 4th period? All right, so here we say X. Okay, the 4th period. Oh, sorry. No, this question is just the 4th period. 4th period. Right, 1, 2, 3, 4, 4th period. And group 1A. So it is group 1A. 4th period, group 1A. So you have to get your periodic table and see up to the 4th element. So I have hydrogen here first, lithium, sodium, potassium. So you know we are talking about potassium. So we put potassium plus. 4th period 1A reacts with 3rd period 6A. third period 6A. So third is this. You go all the way 6A or 16 group. When I look at it, I get sulfur. So when you're looking at it, hydrogen, helium is the first period, okay? Because this here starts with oxygen, then sulfur. That is not the second period, it's the third period. So make sure you clearly get that. So fourth period 1A is potassium, which you know is like that. And third 6A or 16A is sulfur. Okay. So because it's 16, you have 2 minus. What you get? A2S. Okay, so all these questions to do with naming compound and formulas. They ask you what is the name of this compound. It is potassium bromide. The rules. Okay, potassium bromide. Next one. What's the name of the compound? SF4. So you put sulfur. Then I'm going to put mono sulfur. This is 4, so tetra fluoride. Ending with I, fluoride. Sulfur tetrafluoride. Okay, we have different kind of compound. What is the name of Ft2CO33? They're asking the name. Okay, so how do you do that? Because this transition metal coming. So first one is iron, and the other one is carbonate. You know, carbonate is 2 minus. These things you need to know. Okay, so if you had carbonate, sorry, carbonate 3 minus. So carbonate is 3 minus, and then the other clue is you have had 3 here and 2, right? So that carbonate 2 minus. Okay, carbonate 2 minus, and then go back and undo this whole thing. So let me do. So we have Fe2CO3, right? That's 2 minus. So if it's at the beginning, it must have been like that. Fe3 plus CO3. Okay, so this is as 2 minus, please remember that. So 3 plus 2, so then it all became. So iron naming of this sort of compounds, we put Roman numerals the charge. So iron 3 carbonate. Carbonate acid is carbonate polyester. Iron is acid. The only thing you do is you put here the Roman numerals, the charge. How do you find the charge? We say you don't even know this carbonate, but from this formula, as long as you recognize this as a polyatomic anion, you know 3 is here. So 3 must have been up here, 2 must have been there. Those are the charges. So we need only the 3 charge. That's why I put 3 there. Okay. Okay, once again, the name of CaCl2. So we follow the same thing. We undo it. So 2 plus Cl minus, right? So we copper 2 plus. Even if you know not negative, you can find that from the number. Copper. Asking the name of this. What is the polyatomic anion? Okay, so this thing is something you have to remember. This is ammonia. Go through the worksheets on your lecture notes on ammonia. What is the charge of tungsten? So they're asking the charge of tungsten in this compound, W2O5. What did you go back the way I told you? So you get W5 plus and O2 minus. So the charge would be 5. so we have question. It says nitrogen combines with fluorine F to form NF3. What would you expect if nitrogen is combining with iodine? So because they are on the same group, it has to be Ni3. But if you go back and see the charges and crisscross method, you get it. But easiest is because fluorine and iodine same group, and so iodine will have 1 minus, nitrogen will have 3 plus. The compound would be Ni3. Formula would be Ni3. All right, this is a question about asking how do you have empirical formula. Share it again. Okay, they're asking to determine the empirical formula of a compound containing aluminum, 22.1%, okay, and then phosphorus, 25.4%, oxygen, 52.5%. What do you do? You divide by respective molar masses. So aluminum is say 27. Phosphorus, I'm rounding up or down depending on the situation, 31, and oxygen 16. See what you get. Ignore these percentages. Okay. At the compound is given for 100 out of 122.1 divided by 27, I get 0.8, and then 25 divided by 31, I get again 0.80. It's a 0.81, and oxygen 52.5 divided by 16, I get 3.2. Now the smallest one is 0.81. So if I divide by 0.81, I get 1. Okay, this is 0.1, let's say 1, roughly 1, and this is 3.2 by 0.81, 3.81. I get 3.9, we'll say it is 4. So the formula will be LP. Okay, then they're given C10H10O5 and asking what is the empirical formula. What is it? You divide by the most common factor, right? So 5, the highest common factor. C2, that's the empirical formula. Okay, they are given an acid. They say aconitic acid, CHO. They have given that. So this is the empirical formula. Okay, they're saying the molar mass or the molecular mass is of this acid. Of this acid is 274 grams. So they're asking what is the molecular formula? Molecular formula, that's the question. So find the empirical formula mass. Empirical formula mass is C plus H plus O, right? So that is 12 plus 1 plus 16. Okay. So 12, 22, 20, 29, right? So I get 29. Now molecular formula gas is given. So 174 divided by 29. You know how many CHO empirical formulas are there? So when I divide 174 divided by 29, I get 6. That means each one atom I have to multiply by. So I get C6, H6, O6. That will be the answer. Right. They're asking the coefficient of. So if I have Fe plus oxygen, Fe3O, we had to balance it first. So there's 3 there, 3 there, and oxygen 2 here. There's only 1. I put 2 here. Then oxygen balance. Then the ferric to balance. I had to put 6. Okay. So they're asking what is the coefficient of oxygen. There's 2 oxygen. I think there's a not like that. So let me erase this one. Rewrite this question should be coefficient of oxygen. That's fine. But it should be Fe plus oxygen giving Fe2O3. So if I put Fe2O3, then it makes sense. Then 2 here, 3 here. Right now, let's see. If I put 4 here, then I had to put 2. Then 2 to balance this 6. I have to put 3 here. So coefficient of oxygen, Fe, oxygen puts Fe2O3, and to make it 2, I put there, then I become 4. To make it 2 and 3, 6, I put 3, so the coefficient would be 3. Okay. Then once again the coefficient of HBr. So let's see. SB2 S3 plus HBr SBr3 plus H2S. Okay. So the coefficient of HBr. Okay, so let's balance it. SB2 here, so I put 2 here. So bromine, I should have 6. I put 6 here. Let's see. Sulfur 3, I put 3 here. 6. Hydrogen 6. So hydrogen 6 is fine. 6Br is fine. 2sp is fine. S3. Right, so everything's balanced. So the coefficient of HBr would be 6. That's okay. What is the coefficient of carbon? So CSO2, CS2 plus CO. That's the equation given, right? So carbon, right? Sulfur 2 here, so I put 2 here. Then oxygen, I need 4 to make it carbon 4. Then the coefficient of carbon would be CSO2, CS2. Right. Okay, so there are 2 carbon atoms, right? So 4S2 is here, right? S2, oxygen 4. If I put 4 here, oxygen 4, that's right. So carbon should be 4 and 1, 5. So this should be 5, right? Once again, 5 carbons, 1 and 4, 5. That's right. Sulfur 2, that's oxygen 4, oxygen 4. So the coefficient of carbon would be 5. Okay. coefficient of oxygen. Coefficient when the reaction is balanced. So we have C8H18 combustion reaction. This is there given on the CO2 plus H2. So I'll start by putting the carbon 8 to match it. 18 here. I'll put 9 here to match it. Then we'll see whether we can get the oxygen. That's 9 and this is 16. Okay. So 9, this is 16 and make it 25, right? So it's an odd number. So let me put 25 here and see whether it matches. 25, that's 50. So I have to match it to 50. I can double it, right? So if I double this one, if I put 2, make it 16. Then 6, so I make it 18 and 36. So let us see oxygen. So, okay, first of all, balancing 2 times 8, 16 carbon, that's fine. Hydrogen, 18 twice, 36, that's 36, that's right. And oxygen, 16 plus 2 is 32 and 18. So 32 and 18 would be 32, 50, right? So 32 plus 18 is 50. So here 25 times 20. So it's 50. So coefficient is 25. Okay. It's a bit difficult to balance first one. It's clearing these things up. So it's clear for you. Okay. So then you see it's 25. Okay. All right. A few more questions here. The coefficient of, so these coefficient questions are very important because it helps you to balance reactions too. Coefficient of KOH. Instead of asking you to balance at an exam, they ask you the coefficient. So you have to be able to balance it properly to get the right coefficient. Okay, it's 3PO4, K3PO4 plus H2. Okay, let's see how this balance. Potassium 3, so I put 3 here. OH, take them as body atomic anions, then it's easy. So 3 OHs here. We have only 1. Okay, so if I put 3s, let us see. Okay, because you can take it as HOH. Okay, so that's I put 3. Hydrogen, I have to have 6 pure hydrogen, right? So I put 2 here and right, PO42. I don't have to put hydrogen 2 here. So again, go back, PO4 here, PO4, that's right, K3 here. So this part is right. The OH here, there should be 3 OH, right? And hydrogen 3 here, 3 times 3, 6. So here you have 6 hydrogens. Okay, then oxygen, if I take it separately, 4 and 3. So it's 4 here, the 3 here. So this is balanced. Okay. I'll clear these ones now after balancing. Okay, so they ask you the coefficient of KOH, which is all right. What is the observed shape of pH3? Now these are just direct questions. Okay, what you see. So the answer is you need to know how to draw the structures. You find the valences, add them. If there are charges, you add them. If there are positive charges, you deduct. If there are negative charges, you add them. You get the total number of electrons. Then you get the central atom, and then you get the peripheral ones. Okay. So then after that, you add those electrons to ones. Whatever left, you put it in the peripheral. In this case, you don't have to put it. And then the rest you put into the middle because to fulfill that, then you get trigonal or trigonal pyramid. Okay, so Mostly these questions come here, pH3 and H3, things like that. So it may be easier for you to remember rather than drawing during a test. Okay, another question about asking observed shape of NO3 minus. So there's a charge. You can go for the drawing and allocating electrons and then looking for the observed shape. Okay, there's a difference between observed and actual shape, because actual shape means that there are electrons and how they contribute to VSEPR theory, right? But here you just say what you observe only. So here again, regular. Okay, this is a question about which atom is more electronegative. That's which atom is more electronegative. Okay, electronegative. The ones given are oxygen, cesium, sodium, and sulfur. So from the periodic table, you see oxygen is the most electronegative out of this. Okay, out of the four given, out of these four given, most electronegative oxygen. Okay. There's a question about which bond is more polar. Okay, which bond is more polar? So SIF, CLF. They're asking out of these two. So it is silicon fluoride, not chlorine fluoride, because they are actually the same, on the same group, right? So the electron pairing tends to stay here, but maybe slightly towards fluorine. But out of these two, silicon and fluorine bond is going to be more polar. All right, another question like that about more polar bond, more polar compound. CL3, CCl4, SiO4. Although these are all polar, if the polarity is like this, then they get pulled from the same direction, so it becomes non-polar. CO2, although they are polar because they pulled somewhat same. Okay, CCl4 also the same. So the most polar one is PCl3. Right, which one has the dispersion intermolecular forces? They're asking which one will have. Molecular forces. CSO4, Cl2. Once again, so intermolecular forces to happen, there should be polarity. But they're asking which one has the dispersion. Okay. Not ion-induced polar, they're asking dispersion. So dispersion means mostly van der Waals. So SiCl4, because why? Because it's same as CCl4 from the previous example. They're non-polar. When they're non-polar, they become non-polar because they're pulled from the same side. That's why. Otherwise, Si and Cl bond will have a polarity, but when it becomes CCl4, when pulling from all four sides, equally there is no charge because they are balanced. But the dispersion, as I said, the electron pair travels. When it comes to here, it will have a slight negative. That's the dispersion intermolecular forces or van der Waals forces, the weakest form of bond. So in this case, it will be SiCl4. Okay, in case here, dispersion is coming from that. SiCl. Okay, they're asking which one will have each bond out of the ones given. S, NaH, CH4. Whenever hydrogen joins with oxygen, fluorine, or nitrogen, then only that happens. So hydrogen has joined with oxygen here. So that will be the one that has hydrogen bonds, H2O2. Hydrogen peroxide. Okay. Okay, the next question, which will have dipole intermolecular forces. Lithium iodide, OF2, CCl4. This is a dipole, OF2. As H2O. I think this is a dipole. The last question I have here is, which of the following atoms has the lowest selenium, sulfur? It is in the periodic table. You have to look at it. Bromine and chlorine. So periodic table, the electronegativity is highest here. Highest here. So it goes like that, highest, and this. So electronegativity increases like that. So follow this, and then you will see that selenium is the lowest electronegativity. All right, everybody, that concludes the answers to these questions.